Okay, guys, section 5.4 is on imaginary and complex numbers. We've talked a little bit about how quadratics are going to have two solutions, and sometimes those solutions are real. In that case, they're x-intercepts, and sometimes they are not real, and they are imaginary, and that's when the case when the parabola is kind of just floating in air and it's not touching the x-axis. So we're going to start this lesson with just a little bit about what I is. I is defined as the square root of -1, or in other words, I squared equals -1. And in my opinion, really what happened was mathematicians just ran out of something to talk about, so they decided, let's just make up a new topic and let negatives be under square roots. So they defined this to be what I is equal to. And so now we have a whole bunch of new stuff to discuss. But really, if you treat it like this, you'll be able to confirm that all quadratics really do have two solutions. And if those solutions involve i's, then that's going to coordinate to a graph that does not touch the x-axis. Just a little bit about imaginaries before we get too far. A complex number, we talked on I think the first day of school, that a complex number is in the form of a plus bi. And a is the real part and b is the imaginary part. So really all numbers are complex. The number 4 is 4 plus 0i. And all imaginary numbers like 3i, that's complex also. That would be 0 plus 3i. Complex numbers come in usually conjugate pairs. These would be called complex conjugates. Conjugates in general are a plus b and a minus b. They're not opposites of each other. It's not like one is, take one and multiply it by -1 and you get the other. It's just that the second part is added in one and subtracted in the other. And our complex conjugates that we get as a result of the quadratic formula today, they're always going to come in conjugate pairs. You can even graph a complex number. There's probably some applications of this that I don't know a whole lot about, but to graph a complex number, and I might ask you to do this once or twice, basically you just consider the x-axis to be the real axis and the y to be the imaginary axis. And then you graph numbers like 3 plus 4i by going right 3 and up 4. And that would be 3 plus 4i. And you don't write it with a comma like you would 3 comma 4. You do it with a plus sign. And then, you could graph them in all quadrants. This would be -2 minus 5i. I didn't mean to put that comma there. -2 minus 5i, and so on. So they work just the same as regular XY graphing. This is a small topic that I might ask you to do, like I said, once or twice, but we're not going to build on that at all. So don't pay too much attention to that. And so now we're to the real purpose of today's lesson. There is a rule that says any quadratic equation, such as x squared minus 6x plus 73 equals 0, it has to have two solutions. There have to be two things, because this is second degree. There are two numbers that I can plug in for x and make this a true statement. And before now, we haven't dealt with those numbers being imaginary, but there have to be two. So one way or the other, there's two things I can plug in. In this section, the main section of problems, we solve this equation and then check one of the two solutions. So let's solve the equation first with our favorite little formula. -b would be 6 plus or minus the square root. B squared is 36 minus 4 times 1 times 73. So I've got a 4 times 73. Make sure I don't mess that up. 292. Yes, 292. All over 2a. Erase this from evidence. I could do that in my head. So now I'll do 36 minus 292. I'm going to have to go back to the drawing board. $256. Okay, so it's negative because it's 36 minus 6 plus or minus the square root of negative 256 over 2. 256 is a number we don't mind seeing because it is a perfect square, and the square root of 256 is 16. So 6 plus or minus. Now here's an important fact. A negative sign inside the radical is the same as I on the outside. So that's 16I. All right, what really happened behind the scenes is I took the square root of negative 256 and I broke that into the square root of negative 1 times 256, which is the square root of negative 1 times the square root of 256, which was I and 16. And then I just put the I second, like you usually would with a variable. Even though I is not a variable, I put it after the 16. And then I still have that 2 on the bottom. And because both of the top parts are divisible by 2, I can go ahead and divide it and get 3 plus or minus 8i. So those are my two solutions. And notice how they came in a conjugate pair. One of them's 3 plus 8i, and one of them's 3 minus 8i. Just a caution, just because I see it happen all the time, this is not 3 plus or minus 16i. You can't just divide the 6 by the 2. If you're going to divide, then both parts on the top have to divide. So that's a big no-no. Okay, so the first part of my instructions were to find the two solutions. I knew there were two because it was second degree, and now I've found them. So now I just want to check one. The book only asks us to check one of them. So let's check 3 plus 8i. And by checking it, I mean take the original function and plug 3 plus 8i in for x and see what we get. There's my original. X squared minus 6x plus 73 equals 0. Now, if my two solutions are true, or the one that I'm checking is true, 3 plus 8i, then when I plug 3 plus 8i in for x like this, for that to really be a solution, that means that I get a true statement when I plug it in. So let's evaluate this and make sure that we get 0. Okay, so this first piece, do not distribute that 2. Don't make this 9 plus 64i squared. Write it twice and FOIL it. If you can FOIL it without writing it down twice, that's good, but just be safe. That gives me 9 plus 8 times 3 is 24i. Another 24i makes 48i plus 64i squared. Now the second chunk is just going to be distributing the negative 6, minus 18 minus 48i plus 73 equals 0. Okay, so let's see. I've got right away, I've got plus 48i and minus 48i. Those will go away. Then 64i squared. If you think about what the definition of I squared is, since I is the square root of negative 1, I squared is negative 1. So I get 9 plus 64, minus 64. Another kind of summary way to sum this up is an I squared just changes a sign. Plus 64i squared is negative 64, and then the I squared's gone. Minus 18 plus 73 equals 0. And you can check that these numbers on the left do in fact all add up to 0. So we get a true statement, and that's what it means to have a solution to an equation. When you plug that solution in, you get a true statement. All right, so that's the heart of this section. There's a few questions about graphing and then a few problems at the end that we might look at, but for the most part, that's our goal for the day. Use the quadratic formula, find solutions that come in conjugate pairs that have imaginaries as a part of them, and then take one of those and plug it in and confirm that you get a true statement. All right, so that's 5-4, imaginary and complex. Hope you enjoyed it, and I will see you in class. Young out.